All right, so this meeting is a chance for us to sync up and talk about our plans for signing artifacts within the GitLab runner. We've had a lot of discussion back and forth in Slack, as well as on the epic and the issue. So given the nature of the back and forth, I thought it'd be good for us to all get together and just level set around what our current thinking is, what our plans are, and at least on my end, the most important thing is I just want to make sure that whatever we design is going to work for to allow us to also be able to sign containers and packages. Because even though like the current issue and epic that we have open focuses on build artifacts, eventually we want to be able to sign everything, not just that. And so I want to make sure that that is the right place for us to start. And I just want to make sure that we'll be able to easily extend support out to those other types of artifacts, signing containers and packages rather than just build artifacts themselves. Um, but yeah, that I guess it's mostly a question to the engineers, but I'll open it up for discussion.
Hey, so I've got like a ton of notes, and this is actually my first question, my first line in the notes. Uh, because I read through your comments in Slack about like how we want to support the parts from artifacts, all the other things like packages and Docker images, and with that in mind, I'm not sure we can have signing in the runner. Like, if you want to build Docker images, do we want to force you to use some helper function to build the images? What about packages? Uh, Artifacts are easy. We transparently support them right now, but that's not the case for packages or Docker images or whatever else.
Yeah, I think the same thing. I was considering in my head like how we could possibly do it natively if we wanted to go that path. And I think like it's theoretically possible that we could extend the CIYAML syntax to have like a native awareness of various artifact types, right? So like I was thinking like for example, um, Docker build allows you to write to a tarball, right? npm build, like creating an npm package, you can write that to a tarball, right? So we could instruct users to do that in their build process, output them as artifacts, and have CI syntax that would allow the user to specify, hey, this is the path to my tarball that contains a Docker image, and this is the registry and tag that I want the runner to push that image to, as well as perform signing and whatnot at the same time. But I I don't see a ton of value in doing it that way. I think it adds complexity to the build because rather than doing what you do on any CI platform in terms of Docker build, Docker push, you now have to modify the build steps to be platform specific and interact with our runner specifically. Um, and even if we did do all that, I think just the whole configuration would be more verbose for the end user than just doing it the way you would natively with all these tools. Um, yeah.
Well, I mean,
And
it's just posing this as theoretical. Like cosine, you say I want to sign this image at this registry, URL, whatever, right? Like in theory, we could point it, we could have a URL that said, natively just sign that container image as well, right? But you would have to add a lot of logic to download a Docker image and sign that, right? Is that what you're thinking here? Is that you add more complexity with every package you need to support because you now need to add that to the runner?
Yeah, exactly. And it's like where do you stop, right? If we're adding like package manager API specific implementations for signing, like what's the difference between that and building the package to begin with, right? Like the logical conclusion of this is like, should we enable should we teach the runner how to both build and sign an npm package and build and sign a Docker image? And I think the answer is like obviously no. But I don't know why we're thinking about signing as different from building, right? I don't know what's specific to signing that we would treat that differently from really anything else you can do in CI.
That's a very good point. Uh, I guess I mean some can answer to that, but we mostly wanted it to be very easy simply because nobody else is doing it the easy way. So we wanted to take all that burden away from the user, but yeah, after all, building and signing aren't that much different. So why take away the power from one but leave it for the other?
Yeah, and I think that like for I've been having trouble seeing how users would use the generic artifact signing, but if there is a place where we're going to have signing enabled by default, I think that makes sense on generic artifacts, and I can see a case for having that be on by default, right? But that's because it's like we're running our own package manager, right? Like we control that API and we control how that works. So us owning the implementation of how such artifacts get signed and having that be embedded kind of makes sense to me. I just don't think it also applies to other package managers and other build processes and other artifact types.
So when you say other package managers like npm, at the end of the day, well, how's npm doing it differently from like, you know, um, let's say we produce a dot, whatever npm or whatever it is. How's that? How's the signing different from, if we had our own native thing, just add a signature to it? How's the npm signature different?
Yeah, so npm hasn't implemented it yet, but it's going to be baked into the CLI client. So they are actually building Sigstore.js, like a JS library for Sigstore first, and then they're leveraging that library in the npm client to do signing as part of the publish. So it's all going to be embedded, and both client side and server side npm is going to have a native awareness of these signatures.
Got it. So if we had our own thing, we might be doing double signing almost. We would be wrapping our own Sigstore signature, and then npm would have their own, and it just wouldn't really
Yeah,
work
plus it's like
together.
again, I think like the us having any signing on by default for the case of like a npm package, it would first require that the user like writes the package to a tarball that gets uploaded as an artifact to our system for no reason other than for it to be signed, right? But that's completely separate from the workflow of actually publishing the npm package. Now it'd be different if
Yeah,
like we were going the step further and saying like in the CI syntax you were specifying, hey, here's this tarball and I want you to publish it to this registry and make sure that it's signed, right? But we're not going that far. We're just trying to do signatures, and the user still has to do everything else on their own.
and also with Sigstore becoming so popular and npm adding it natively, if we go the route of adding some of this functionality to be built in, at some point it's gonna get obsolete.
Yeah, like
So
superseded by package manager specific
yeah,
APIs.
now it's npm, then it's gonna be, I don't know what else. Maybe Docker's gonna add that at some point as well. That's gonna make total sense.
So how we think we're doing this? Just use Sigstore and not implement it in the runner? Like George, if you're just doing this the simplest way, what would you do?
Yeah, I would say do it the same way GitHub is doing it. they're just giving us I don't even know if these sections are actually official, but GitHub and Cosine have a mutual understanding. So if GitHub exposes a couple environment variables and you run the sign command, and these variables are accessible by Cosine, it's automatically gonna use the JSON Web Token and sign the artifact. So all you have to do is use the action where you say cosine sign something, and that's it.
Yeah, and I think forgive me, I don't know how to pronounce your first name. Is it Georgie?
Yeah, that's fine.
Okay.
No worries.
I think in order to achieve what you're saying, which is that we basically build like pre-built CI templates or whatever for each package manager. You know, doing it the same way that GitHub does it by the actions for this stuff are not official, but it doesn't really matter whether they are or not. The fact that like all the logic for not only like building a Docker image, but then also doing the signing and pushing it to a registry, pushing both the image and the signature to the registry, and encapsulating that entire workflow as shareable config is the actual problem that we need to solve here, because it avoids the temptation to embed a bunch of behaviors in the runner specifically, because we can just externalize them, and like we'll probably still maintain them ourselves. We'll probably still be first party, but like pushing it all into user land where we don't have to like support everything as it's announced, right? Like allow users the ability to create these shareable configurations for various package managers and various types of artifacts that need to be signed. And I think that like the CI pipeline components proposal is the closest thing I've seen for us to be able to provide similar functionality to what GitHub does and other CI providers. Because like my take, for example, is that like, and I mentioned this to Stan the other day, is like I don't even think that like the uploading of artifacts needs to be built into the runner, right? Like that's just an API call, right? And so like it would make more sense to me if we had like a first party step that you could append to the end of a CI job, right? That took artifacts at this path and uploaded them to our artifacts upload endpoint, right? I think we have a ton of behaviors that are embedded into the runner that only need to be because we don't have like modular steps at the job level or composable steps at the job level.
That's a different discussion,
Yeah.
right? Than today's discussion.
Yeah, that's
sure. Yeah, I don't know. It's much
Yeah.
broader, but I think
Yeah.
I think it's all analogous. I think it's all related.
that's a big discussion.
Yeah, but GitHub doesn't actually provide anything specific for package managers and all that. All they provide, and that's not even official, is an action to install cosine, and then you have to run the commands manually. So they don't provide you with anything. All they provide is the way to get the JSON Web Token, the OpenID Connect token.
Mm-hmm.
That's all they provide, and that's coupled with cosine. But it's limited to that.
Yeah, have you seen the sorry, hang on, I'm trying to grab a link here. There's this project
This this YAML file that they have demonstrates basically all you have to do to publish and build a assigned Go binary. So if you look at this YAML, the key step is on 42. It says they just run cosine, but the magic happens because they have two environment variables that are set during this process, is one of which is like the URL to go fetch the token, and then I think it's the GitHub a build token that they're exchanging for the OpenID Connect token. And so this happens kind of transparently. Cosign's like, oh, okay, I see these environment variables. I'm going to go get this token. I'm going to go sign it. And then I'm going to, do all the things I need to do to prove that I signed it. And then the last steps on this YAML, this recourse stuff is basically the verifications. Like, hey, you've signed this thing. This is the transaction log that shows that I signed it, and this verifies that this was indeed built by this runner. So I do think there's a case to be made just to make this easier and to make GitLab, work with Cosign, just out of the box. I think that's one of the main requirements here. Just like make it much easier. I think the initial push was to make it completely kind of transparent, but maybe the first step is just make it easier to use Cosign, because right now it's a real pain. You have to either configure a private key, which I think we didn't like. OpenID doesn't quite work. I think there was one proposal in that issue about using an OpenID secret and client secret, and that's another way to go about it, but you would still have to keep that client secret for that runner. So that's another problem. And the way GitHub is working right now is it's saying, well, the job is really what I want to authenticate. I don't care about the runner. The runner itself, you could have 100 runners. They may be ephemeral, they may go away, but I really care that this job defines the process by which I built and signed the artifact. So when it goes and it gets there's like a job ref, it's basically like a link to this action at this commit ID, so I can prove that this was built. So that's the way they do it right now. Our GitLab CI YAML is a little bit different in the sense that you can include other CI YAMLs, and then you might have to, like, if you really wanted to say this is the job that actually did this thing, you would have to kind of bundle all that together. It's doable. But maybe the first step here is just make Cosign, do everything we can to make Cosign just work really easily with GitLab. And then we can think about, okay, do we want to embed this within the runner itself, or just put this within a CI template for now, and then talk about reusable components kind of down the road?
Yeah, I completely agree with you, Stan. And another important thing you touched upon is the identity of whoever or whatever signed the build artifact. That's something we talked about a few times in the issue. I think the idea of signing an artifact or whatever is just to prove that it was signed somewhere on some specific place, for example, a build job, and not that it was signed by something specific or that it can be reproduced. So essentially, if I am a bad actor and I gain access to your CI, yes, of course, I can generate a signed artifact. But I mean, that's okay, because at some point this has to come from somewhere. All these tokens, they have to be accessed from somewhere. So having the build as the issuer of these artifacts, I think that's completely fine.
I'm not as sure of that. My understanding is that it's really important for that signing token to only be accessible by the signing service, but not the build CI itself. Like, as you said, like, if a bad actor does gain access and is able to, sign a malicious artifact, then how can you trust that signature at that point? Like, I would think that secrecy of the token would be key in order for it to be able to be trusted.
So I think it's more related to like what Stan was saying. Like, really what you're trying to prove is that the artifact was produced with a known, like, trusted builder workflow, right? So that, like, the build process itself is immutable, even from like a project maintainer's perspective, right? Because, like, a malicious actor, like, the whole point is that, like, a malicious actor, it doesn't matter what level of control they have over your repository per se. Like, even if they are able to trigger a CI job and build some artifact, the artifact was still produced using this external build process, which generates the provenance metadata and signs it and everything, right? So I think that avoids the problem that you're getting at, because certainly you can introduce like malicious code, right, to the project. But the point is that like the build process itself is immutable, and you're making it cryptographically verifiable that that's the case, and that this artifact specifically was produced using that build process.
Right. I would just think that they could modify, if you're running like in a test branch or a development branch, you could modify the build process itself. So you could modify the steps taken to do the build and then tamper with the file itself to change the steps that are published in the attestation and then sign it. That's what I
It
would
should
want
be
to
all
avoid.
auditable, right? You should have the branch that was made with that, and it should have all the commit IDs so that if they do produce artifact, you go back and say, okay, where did they build this? If they built it off this crazy branch, that should not be, I should not use this artifact, right?
Right, but if
And
they're
it's like the
able
whole
to sign, then they could tamper that with that attestation and basically change it to say that it was built off of the default branch instead of a development branch. Like that would be the concern.
Right, but if we sign in the current process, they sign it with this ephemeral key. You can't go and hack that, attestation without that signature being invalid, right? If you happen to have this secret key that you knew that you could just change attestation, I can't even say the word. This file, then it means that like that's the reason why you don't want to have this key available to even like the build process, because if you're able to go and muck with that file, then all bets are off, right? Well, that's your
Right.
right. So this is why this key is ephemeral. They just sign it, they toss away the private key, and there's no way you can go and create this file again unless you redid the build process in the right way.
And this also like touches on like the differences between like salsa level 1 and salsa level 2 and 3 and beyond. Like I don't think salsa level 1 requires that your build process and provenance generation be externalized in the same way that salsa level 2 and 3 do, right? So I think Sam, in the use case you're laying out, like you're talking about like a maintainer hijacking maintainer access to a project and then modifying the build process within that project, right, and tampering with
Right.
it at that level.
Well, or even
That,
in a separate branch. Yeah.
yeah. But like if you're relying on like a trusted first party or third party build process, right, it doesn't matter anymore, because like as a consumer of that package, all I care about is that I can verify that this artifact was built using this build process that I trust over here, right? So it doesn't really matter what the user is doing in their particular project, right? Because like I trust the build process, and I
You trust the
trust the
build process, but
provenance.
you also trust that all the metadata in that process tells you exactly what was built, right?
Exactly, because it can't be
like
modified by the project maintainers that are using that build process. Like they can't tamper with how provenance metadata gets generated, because that's encoded in the thing that we all trust, which is the build process.
But yeah, if they can generate their own like manifest file and just say, hey, this was actually the main branch, right? Then you have a problem here, right? Like that's the problem with having these secret keys that can if you happen to get access to that secret key, I can generate like, oh, this is now the main. I just faked my binary to look like the main binary, the main branch or whatever, right? Um,
Right. So
it's a cool threat. Go
my
ahead.
concern would be to make sure that in that scenario that someone was not I mean, I know we're using an ephemeral key, but if the process for creating the key isn't private enough, if that malicious build process or whatever is able to go generate a new ephemeral key, sign their tampered, attestation, then you have a problem as well. So you have to make sure just the key being ephemeral itself isn't enough. You have to make sure that the process to obtain a key is also private and secured in a way that the build script itself doesn't have access to a means of generating a private key.
Yeah, and that's right. And I think the way the GitHub does it is right now they say this is the job. They know exactly what job got that key now, right? Like I can tell you exactly the YAML file that was used to access make that key, and so I can then go and trust that. So there's just, you have to look at the threat models, right? What level of, what do you trust, right?
Well, and I think the keyless signing workflow in particular bypasses a lot of the concern, right? Because like there's certain things that have to be true for a job to have a CI job JWT token to begin with, right? Like we know that was issued by GitLab for this particular job. We then rely on like a service like Folkio being able to verify against the GitLab server that this token is valid and was produced by GitLab itself, right? I think there's all sorts of threat models that you need to concern yourself with if you're doing the key management yourself, but that's sort of like always true, right? For any sort of secret in your CI job. So the point being, I think that's why we need to focus on the keyless workflow, because that's easier for us to ensure secure defaults around than any of the like BYO key type stuff, right? We'll have to like evaluate that much more thoroughly and provide good recommendations for folks on how to do that key management. But that's hard. So let's just leverage Folkio and do the keyless signing first.
So I
that
know
brings
we're
up
pretty.
questions and stuff. Anyway, sorry, go ahead, Sam.
Go ahead. Oh, I'm
No,
sorry.
I just think Folkio is a whole different, there's very GitHub oriented right now, right? And so we would have to, they're talking about having a generic job reference, right? Because right now GitHub has a very specific meaning of what it means to have a job reference. And, we have our own ideas. And so they had that issue open about how to support everybody else, but I don't think it's gone anywhere yet.
Yeah, and I've been in touch with those folks, and they're certainly like open to collaborating with us. Like they want to figure out what works across multiple CI providers as well. But I do think it's a really important problem to solve, that all CI providers have either the same exact claims on tokens that they generate, or like things that can be easily mapped to the same concepts, right? I think we're in a better position than most providers to be able to tweak the claims that we expose, since there's been a lot of work going into the CI job JWT stuff lately. But I think we could contribute the necessary changes to Folkio, or at least coordinate with them to make GitLab like a first party. And that's all the stuff that's in the comment that I made on that epic, I think, is what is needed to get that done. But we just need to do it. I don't think anybody's gonna give us a hard time about it.
So I know we're out of time here. I just want to, before we wrap up, so if we go down this proposal of making it easier to use cosign out of the box rather than integrating it into the GitLab runner, is there still a path forward if we want to use that as an MVC and then eventually get to the on by default? Or, on like, is this a path towards where we're headed in product? Or is this like, does this take us in a completely different direction? If we did eventually want to do signing directly in the GitLab runner, or embed cosign in the GitLab runner itself so that it just happened. And, if we did add support for, individual package managers or Docker images or something like that, is there a path towards that in the future, or are these two totally divergent paths?
I think this is a path towards that if we wanted to go that way. I think it enables that, because we have to do this work anyway to make cosign work nicely, right? And so if we have that support, we can say, okay, we can push this down to the runner if we really want to. So I kind of see it as like the first step. And if we want to, totally embed it, we can do it. If we want to make it a separate CI or whatever, we can also do it that way too. So I don't think it kind of takes us in a direction where we can't, it's not like a fork in the road here. I think it's a path we need to take anyway. Would you agree with that, Marshall and Georgie?
Yep, I think it's spot on. Any work that we do related to GitLab integrating with Folkio and Cosign just means less code in the runner if we go to embed Cosign in the runner. Otherwise, we need to configure and like parameterize Cosign with all the stuff that would just be native to it.
Got it. Okay, well, thanks everyone for that today.
And before we wrap up, Sam, I just have one quick
Go
question.
ahead, Darren.
Before you wrap up, the make it easy to use Cosign steps, are those steps already in the issue, that long issue thread, or do we have to async document those steps somewhere else?
I think there are a few steps in there. I don't know if we covered it comprehensively yet, but we can add to that epic or the issue.
Oh, if anyone who knows what the steps are, just add async to this doc after the call. So we can kind of map out what needs to be done, because I think it's all over the issue right now. That'd be awesome.
Agree. Okay. Is everybody happy? Do we need another discussion later, or?
I think I'm good. Is there somebody who can take the lead on making sure that we've got issues for each of those steps? I think that would be the action item out of this. Do we have a DRI for creating those issues?
I can create the issues. If to keep the burden light for Stan, Georgie, and Marshall, just make sure the steps are in this doc somewhere, right? And then we can figure out how to create the issues. So don't worry about creating issues. Just lay out the steps, like what we need to do in this doc, and then I'll take a lead on the issues.
Okay, thanks so much. And we can use the channel to kind of async discussion, kind of figure out what we do and we don't need to do.
Sounds good. Well, thanks everyone for the time today. Appreciate it.
All right, cheers, everyone.